Hello everyone. This is continuation of our series on mathematics, vectors and calculus. Till last lecture we talked about differential calculus. What is differentiation? What is the application of differentiation, right? So in this lecture we'll continue the application of differentiation and we will move to the another sub branch of calculus, which is integral calculus. And today is the last lecture for this mathematics topic, right? From next lecture we will start on the physics kinematics, right? Okay. So if I can recap you, uh, so we talked about the parameter called dy by dx, right? Dy by dx. And what is the application of dy by dx? How it can help us to measure the rate, right? So now let's talk about applications of dy by dx, right? So before going to the applications of dy by dx, let's solve one numerical or a problem on dy by dx, right? Okay. Let's say if y in function of x is given by e to the power x into sine x, right? If this is y equal to e to the power x sine x, we need to find what is dy by dx, right? What is dy by dx? Okay, so dy by dx is also indicated as f dash x, right? So first differential of fx. So we need to find what is dy by dx, right? Okay, let's solve this particular problem. So you can see in this particular function we have two functions multiplied. E to the power x is one function, sine x is another function, right? So see, we discussed a multiplication rule in differentiation. What multiplication rule says? If there are two functions in x, which are u and v, then d by dx of u into v is nothing but u into differentiation of v added to v into differentiation of u. This is the product rule of differentiation, right? This is what it is. Now, if I compare this function to this function, now you see, I have I have u as e to the power x. I have v as sine x, right? Now can I directly use differentiation here? The product rule, right? So dy by dx is nothing, but as I said, it is u dv by dx plus v du by dx, right? So e to the power x will come here. dv by dx means d by dx of sine x, right? Plus v is nothing but sine x and then d by dx of e to the power x, right? Okay. So we have already discussed differentiation of some standard functions, some trigonometric function, exponential functions, linear functions, right? Okay, so dy by dx of sine x is nothing but cos x, right? And dy by dx of e to the power x is e to the power x, right? So dy by dx of this function is nothing but e to the power x cos x plus sine x into e to the power x. I can take this e to the power x common, which basically means sine x plus cos x, right? Okay. So I'll give you some assignment to do for yourself and then we can discuss it in the next sessions, right? Right. So these are four functions given in this is y is in function of x. You need to find what is dy by dx, right? Which is basically f dash x, the first differential of x, right? So yeah, this is how it is, right? Okay. So let's move to the next topic in this series. So next topic here is maxima and minima. Maxima and minima, right? So let's understand analytically what is maxima and minima, right? What is maxima and minima? Okay. So this is y as a function of x, y as a function of x, right? If you see this curve, this can have multiple tangents around at all different points, right? Now, if I am asked to find at which point on this curve attains the maximum value, or at which point on this curve attains the minimum value, I can use dy by dx to help me with this particular problem, right? So if you see, these tangents have different slope, right? These tangents have different slopes. But if you see analytically this point, which is the maximum value of this curve, if I draw a tangent at this point, this is nothing but parallel to x-axis. So what is dy by dx here? dy by dx is 0. Slope is 0. Slope is tan theta. So the angle with x-axis is 0. So tan 0 is 0. Again, for minimum, you see this is the point of minimum. And if I find dy by dx here, this is again 0. Right? So I can say that if dy by dx equal to 0, then that point is either point of minima or point of maxima, right? So I'm still not clear on whether it is maxima or minima, but it is one of them. If dy by dx is 0 in a particular domain, let's say this is what my domain of this function, then the point can be either point of minima or point or is or can be point of maxima, right? Okay. Now, if you see, I explained that dy by dx is nothing but slope of the tangent at any curve, right? Okay. So if you see difference between minima and maxima, if you observe here, maxima is existing from a point where if I draw slopes here, all these are positive slopes, right? The left of maxima, all these are positive slopes, right? The positive slopes means dy by dx is greater than 0, right? But on the right side of it, you see these are negative slopes. Dy by dx is less than 0 for point of maxima, right? Which is reverse in the case of point of minima. You can see on the left of this particular point, I have the point of negative slope, but after moving ahead on the right of this point, I have the points of positive slope, right? So for maxima, slope is changing actually in the direction of reduction, right? So first dy by dx was positive, then it became 0, then it became negative. For minima, first it was less than 0, then it became 0, and then it became greater than 0, right? So if I calculate the change in slope itself, it will be negative for maxima, right? But if I calculate change in slope for minima, it will be positive. So what exactly is change in slope, right? So let's say if dy by dx is slope, this is my slope. So change in slope is nothing but differential of this slope again, which is differential of dy by dx with respect to x, which is nothing but double differentiation of y with respect to x, right? So for point of maxima, this particular quantity is negative because it is in the decreasing direction. First is positive, then 0, then negative. But for point of minima, this particular quantity will be positive, right? Okay, so we started like when dy by dx equal to 0, the point is either point of minima or point of maxima. We are still not clear because it is not unique how to find whether that was a point of maxima or point of minima. So we calculated d2y by dx square, and we say that when this is less than 0, it is point of maxima, and when it is greater than 0, it is point of minima, right? Let me summarize it. Okay, so let maxima and minima. So dy by dx equal to 0 is common to both of them, right? Dx equal to 0 is common to both of them, right? But in case of maxima, d2y by dx square, which is double differentiation, should be less than 0, and here d2y by dx square should be greater than 0, which is positive, and here it is negative, right? Okay, let's solve some problem on this particular topic, then it will be more clear. Right, so let's solve this problem on maxima and minima and understand how can we use this in physical applications, right? So height of a ball thrown upwards is h is given by this equation of motion, h equal to ut minus half gt square. Find the time taken in reaching maximum height and also value of maximum height, right? Okay, so what happened is I've thrown a ball upwards. The height is varying with time with respect to this particular relation. We need to find the time taken in reaching the maximum height, right? So here we don't have y and x. Basically here we have height as a function of time, so you can think in this direction, right? So to find maximum height, we talked that to find maximum and minima, we need to differentiate with respect to that variable, right? So can I differentiate height with respect to time and equate it to 0? So this will be either a point of maxima or minima, we just discussed, right? So h is nothing but ut minus half gt square, right? Now if I differentiate h is with respect to time, so dh by dt is nothing but my initial velocity I'm assuming as constant u into dt by dt minus half g dt square by dt, because g is also a constant gravitational acceleration due to gravity 9.8, so u minus half g into 2t, right? So u minus gt, right? U minus gt, this is my first differential, right? Now what is my second differential here? So this is my first differential, and I just said this point can be either minima or maxima, minima or maxima. How can we clarify whether it is maxima minima? For that we need double differentiation, right? So if I do a double differentiation, d2h by dt square, I need to differentiate this, which is d by dt of d by dt, dh by dt, sorry, right? So this is nothing but minus g, which is negative. Hence it is clear that whatever I am finding is a point of maxima and not minima, right? So this let's say this is maxima, so this minima is now cancelled out. We are finding the maxima because we have found the d2h by dt square, which is negative, right? So to find maxima now, I need to equate this to 0. So u minus gt is nothing equate to 0, and t will become what? U by g. So at this particular time, the object will attain the maximum height. And what is the value of the height? You can just place this t in the initial equation and you can find it, right? So h equal to ut minus half gt square, place t. So u into u by g minus half g into u square by g square, right? So u square by g minus u square by 2g, so which is basically by u square by 2g. This is h max. So this is the maximum height it will attain, right? Okay, right, right. So next branch of calculus which we will be dealing is integral calculus, right? We just discussed differential calculus and what are its application, what is its physical significance. Now we will be discussing integral calculus, right? So integration or integral calculus, it is the reverse process of differential calculus, right? So if I say we talk that d of sine x by dx is nothing but cos x, right? So the reverse process of this is integration. So integration is represented with this sign. So integration of cos x and multiplied dx will be sin x, right? So this is the integral is the reverse process of differential, right? Okay. Uh, right. Let's understand more on this. Okay. So let's say this is a function y in f of x, and the function is something like this, right? This is the function, right? So this function, let's say this is defined from a point x1 to a point x2, to from a point x1 to a point x2, right? And if I need to find the area enclosed by this curve, right, I don't have a direct formula. I know the area of square, area of circle, area of trapezium, but for these kind of curves we don't have a direct formula. This is a continuous curve, right? You see this is continuous across. So to calculate area of these type of functions, we need integral calculus. So one of the major applications of integration is area, right? And how do we find the area? Okay, so we will take out a strip from this particular curve, right? Let's say this strip has a thickness dx, right? This strip has a thickness dx. It is at a point x from the origin, right? And this coordinate, let's say this is y. Okay, so what is the area of this thin strip? The area of this thin strip, you can easily say, let's say dA, small area. dA means small area of this strip. It's nothing but y into dx, y into dx, right? And to calculate the area of whole region, I need to have multiple strips of this thickness dx, and then I need to add it all, right? Add means I need to do a summation of this all small ds coming across, right? Which won't be very easily possible because this is a continuous curve and not discrete, and this summation won't be very helpful. So in these particular cases we go for integration, right? So area will be nothing but integration of this function y into dx, and with respect to x it is, so it is from a point x1 to a point x2, right? From point x1 to a point x2, right? Okay, let's understand more, right? Okay, let's say we have a function in x, y equal to x, a very simple function, right? How will the curve look like? The graph will look like this passing through origin, right? This is origin, right? And if I have a point on x-axis, which is let's say 2 comma 0, and I need to find this particular area, right? The the area this is including with x-axis, let's say this particular region of area. What I need to do is I need to go for integration, right? I need to go for integration of this function from 0 to 2, right? But since this is a very simple curve, I can also calculate area via analytical terms, right? Right. Which is what? Which is half into base into height, right? So again, area of this particular triangle will be nothing but half into 2 into 2, which is again 2, right? And this can be also calculated in integration manner, which is integration of y dx from 0 to 2, and y is nothing but x, so x dx from 0 to 2. And if you calculate this, you'll get particular value, right? You'll get this particular value, right? So I talked integration is the reverse process of differentiation, right? Integration is the reverse process of differentiation, right? Okay, so there are two types of integration. One is indefinite integration, indefinite integration or indefinite integrals, right? One is definite integrals, right? Definite integrals. Okay, so indefinite integrals means when we place an integration of fx dx, we won't place a limit here, right? We won't place a limit, right? But in case of definite integral, whenever we place, we'll have a fixed limit, a definite limit, right? And physical significance of definite integral gives me what? Area, right? Gives me area. But since it does not have limit, any physical significance of indefinite integral will give me a I can say pair of functions, right? Pair of functions, pair of functions, right? And if I calculate value of this particular integral, it will be something in function of x. But since it won't be complete, we will always write a plus c here, right? Plus c means plus constant, right? A constant which may be possible, right? Which may be possible that it might be existing with this particular integration, final integration, right? Why we are placing this constant? Because we know that differential of constant is nothing but 0, right? So even if we integrate some 0 also, we may get some constant, right? Okay, so integration of this definite integral of any f of x will leave me with a plus c, which is plus constant, right? But this will always give me a definite value, right? Or maybe a constant value, because it has a definite values, right? Okay, correct. So let's understand the integration of some standard functions, and then we will solve some problems, right? Okay, right. So we will now discuss the integrals of standard function, right? Let's start with function in x. So if integration of x to the power n dx is nothing but x to the power n plus 1 by n plus 1, right? A condition is n should not be equal to minus 1, right? N should not be equal to minus 1. But what if n is equal to minus 1, which basically means integration of d to dx by dx? It will be nothing but log base ex plus c. So this is what is indefinite integral, and we need to place plus c against all of these, right? So here also let me put a plus c, plus constant, plus c, and n is not should not be equal to minus 1, right? Okay, integration of sine x dx is minus cos x plus c, right? Integration of cos x dx equal to sine x plus c, right? Integration of sec square x dx is tan x plus c. Integration of cosec square x dx is minus cot x plus c, right? Again, integration of e to the power x dx is e to the power x plus c. E to the power x, since we have differentiation also as e to the power x only, right? Integration of sec x tan x dx is sec x plus c. Integration of cosec x cot x dx is minus of cot x plus c. So these are what I can recall the integrals of standard function, and I think this should be more than enough for now. In detail we will talk about integrals when we go for class 12th, right? So let's solve some problems on integration, right? Okay. Right. So first problem is I equal to integration of 4x cube into dx, right? 4 is a constant, right? Any constant can be brought out of differential or integral function, right? So I'll bring this 4 outside this integral and I'll integrate x cube dx, right? And we have discussed that integration of x to the power n dx is nothing but x to the power n plus 1 by n plus 1, right? Plus c, right? So integration of 4x cube is nothing but it will be 4x to the power 4 by 4 plus c, which is basically x to the power 4 plus c. So this is the integration of 4x cube, right? Now you see if I differentiate this x to the power 4 plus c, I'll be getting this 4x cube. So we just discussed the integration and differential are reverse process of each other, right? Let's solve one more problem on integration, right? Right. So this whatever we are solving is our problems of indefinite integration because they don't have limit, right? So next problem is integration of 5 sin x dx, right? So 5 is again a constant which can be brought out, right? So it is integral of sin x dx, and we know integral of sin x is what? Minus cos x plus c. So this is nothing but minus 5 cos x plus c, right? If I need to convert this integral to a different integral, right? If I need to convert this to a different integral, what I will do? Again, I'll rewrite this question and I'll place a limit, right? So this is 0, let's say 0 to pi by 2. Pi by 2 means 90 degree. You know, pi radian is 180 degree. So pi by 2 is 90 degree. So 5 will come constant and it is minus cos x integral of sin x, and I'll place the limits now, right? First I'll place the upper limit. So upper limit is minus cos of pi by 2, right? Then I'll subtract it from the lower limit. So this is minus cos of 0, right? So cos 90 is 0, cos 0 is 1, so 1. So this value is 5. So this definite integral is giving me a constant value which is 5. Indefinite integral is giving me a family of curves here, right? Which is minus 5 cos x plus c. So let's solve a different type of problem, bro. Okay, so we just solved uh, what integration 5 sin x means. What if question looks like integration of 5 sin 3x dx, right? What if problem is integration of 5 sin 3x dx. So in problems like this where we have coefficient of x or where there is any constant added to x, subtracted from x and things like that, we go for substitution, right? And then we will convert it to our form, right? So this is integral of this function with respect to x, right? So I'll place this 3x as any variable, let's say t. I'm substituting 3x as t, right? Now let's differentiate this. So with respect to x, so 3 dx by dx both sides. So this is dt by dx, right? So dx by dx is 1. So 3 equal to dt by dx, right? So if I calculate dx, dx is nothing but dt by 3. Now I'm converting everything to t format. Now if I write this integral will change like 5 sine 3t means what? 3x is what? T. So 5 sine t, and dx is nothing but dt by 3. So this is dt by 3, right? So 5 by 3, which is constant, will come out. And now it is simple integration of sine t dt, which we already know. So this is nothing but minus 5 by 3 cos t plus c. Now I'll put the original value of t, which is 3x. So minus 5 by 3 cos 3x plus c. Clear? Right? Okay. I'll give some more problems. Maybe you can try them for exercise. And from next class onwards, we will talk more into the aspects of motion and rest, which is kinematics, right? Okay. So let me write some more problems. Integration of e to the power 5x dx, right? Integration of sine minus 3x dx. Integration of sec square 5x dx. Integration of log 10x dx, log base e, right? Okay, so these are problems related for integration. And yeah, so from next class onwards, we will talk more into the motion and rest, kinematics, and from this series. So this will be the last series on mathematics, vectors, and calculus. Thanks.